You want to start, John, or shall I start?
Yep, you start.
Okay. I will share my screen. Okay, you can see that. Can you see my screen?
Yes.
Okay. Yeah, I'm going to talk a little bit about scripting, or more in generally actually interacting with the COPASI API. And what we do in COPASI, we actually export, make the full API available to the user through a library, libcopasi SE, which is C++, and all the API except the user interface is available. So it's for creating your own programs or applications if you want. You can get that by just going to our GitHub repository and downloading the repository. You can, the build instructions are there. If you want the library, let me go back to the PowerPoint, you will have to add one more parameter to the CMake command, which is actually there's a D missing here. It must be -D COPASI install CAPI equals on. And then you have the library with all the header files and so on, and you can start building your own applications. We provide a next list of examples. So I think that's close to 20 examples of the most common use cases. So you can change values and so on. It's pretty much always the same. You have a main program, you initialize the root container, and after that you are free to interact with the API as ever you want. You can load a model and or create a model from scratch. In this case, we load a model, import an SBML file. Everything is possible. Okay. Next, we also make this available in language binding. Our language bindings basically use the libcopasi SE, which I just showed, and they make that API available in Python, Java, C#, R, Perl, or Octave. The last two are a little dormant, and I don't know how well they work, but the first four are fully supported. So if you want to get the Python, Java, or C# API, you can just jump to language bindings. You can just jump to our website, and you can download the Java bindings for the different OSs and architectures. And for C#, it's similar. For Python, it's a little bit more convenient because we also have it on PyPy. So if you have a Python installation, pip install COPASI, Python COPASI will get you the language bindings, and you can just start using it. And that is available for Windows, Mac OS, Linux distributions. So if you have a Python installation, pip install will make the COPASI API available for you. Okay, again, examples for each of the different languages can be found under the COPASI bindings on GitHub. They are very similar in the interface to what you have seen for the C++ API. You can load and manipulate the model. You can run tasks and create reports. So you can do everything what you can do in the COPASI interface. And if you, you can freely interact with the bindings. Next, for R, we provide the language bindings, but in addition to R, it's one of our close collaborators who's been in the team for a long time, Jürgen Pahle, has created a COPASI R connector, which is actually provides the data generated from COPASI in R data structures. So it is very easy for you to run multiple time courses for stochastic simulation and create statistics and things like that. So this is also available. You can just download it. It is a website. The website also provides examples, and yes, all the instructions are there. And if you can work with R, you should be able to pick up with the R connector of COPASI quite straightforward. And furthermore, we have the same basically for Python. This uses pandas data structures to provide access to the data created in a time course or in a steady state calculation or in a scan, whatever you do for Python. So that is built on top of our Python bindings, so that adds functionality to it. And again, here's how to get it, and there are examples in read the docs. And finally, that is not just something which is available for you. There are actually a lot of people who have used that. And if you look for examples, for Python, we have the Pico tools, which are provided by CRM Welch, and there's a paper doing that. Cell Designer, a tool which you might have seen. It's a graphical front end for creating SBML models. For the simulation, it is possible to use COPASI and Cell Designer. So that uses a Java language binding. Actually, it uses an old language binding where we specifically for Cell Designer also had an interface to the Qt GUI. Then there is a project about lipid metabolism that uses NetLogo and the COPASI C API to create agent-based model, and the larger agent-based model framework Flame that used also the language bindings to have models from COPASI. And furthermore, there are actually 3 tools available on the COPASI website, which are in Java, and they all use the Java language bindings to the libCOPASI SE. So yes, that is basically what I wanted to share with you. I just want to make you aware that all this is available. Furthermore, I actually forgot, you can run COPASI from the command line, and which is actually done in Condor COPASI or Cloud COPASI, which is we are working on to provide service for high performance computing. So you can run COPASI on the cluster by just running COPASI SE. Okay. Any questions?
I think there's a question in the chat from Ben.
Let me get back to so that I see it.
Around core to work with our.
I don't know, but I suspect it since it's under active development. Cork. Any other questions?
Well, there's a question from Jasraj, but regarding VCell, about I will have to come to that for later in the afternoon because I have NIH study section coming up, and I will not be available until after 3 p.m. But Jazra, I'm happy to jump on that after 3, or at some other point later. It doesn't have to be part of the workshop.
But you're supposed to talk about that now,
Yeah,
right?
I will talk about it now. Yeah.
Okay, good.
So let me go back to share my screen. Okay, so VCell has also, we have developed a programmatic API that is available as a REST API through, because of the VCell client server architecture. So you can get this at, you can look at it at this link at VCell API beta, where you can sign in with your VCell user ID. And let me do that. So I'm logged in with my VCell user ID, and I can see all my, by default, you will just get a web page with the query of your latest 10 models, and you can click on a particular model, you can download the SPML, download the VCML, you can look at simulations defined where you can change parameters and check the status of jobs, run simulations through the API. And this is actually also available not only through the web, but through commands that are documented on our GitHub site. However, we are discouraging the use of this initial API implementation of VCell because it will no longer be maintained, as we have integrated VCell into another infrastructure that is part of the biosimulations project that includes both VCell and COPASI, as well as many other simulators. And here's a link to the paper that has been published last month, describing all the infrastructure of Run Biosimulations, which is a web application that uses standardized Docker containers of multiple solvers, including VCell and COPASI, that you can use either on the web through free services or download the respective containers and use them independently on your own HPC platforms with a standard user interface where you specify an input in the format of an OMEX file, which is what's called a Combine archive. So if you Google Combine archive format, you will find the specification of the Combine archive, the OMEX specification, which is nothing more than a glorified zip archive that has metadata information about simulations and task specifications and model specifications inside a zip file with a metadata that points to the various components of the archive. And the web service is biosimulations.org. Where you have 2 available links at this point. Hopefully within the next year or so, many of these grayed out links will become available. This is actively being developed by multiple collaboration of multiple institutions. But on the simulation tools, you will find a registry of the simulation tools that have been standardized to work as containers with the exact same command line interface using the Combine archive as an input file. Hopefully this will load up. But as I said, this is very, very new. Just became available last month, so you may find things that may or may not work yet. If we would have had this workshop like last year in August, this would have been all production quality, and but basically you would be able. Okay, so here you have the full list of all the tools. You see COPASI here. You see the curation status. The curation status 5 stars means that it is validated to actually run properly given the standardized input format, and you can actually execute simulations through the web, or you can download it and run the container from the repository to run it on your HPC background. So you will see that you have FullNet, CMPI, CobraPi, COPASI, Gillespie for stochastic, and VCell and Tellurium and Smolden are fully curated tools that can be run. So if we were to choose COPASI, hope this actually
It's very slow.
works. Yep. And you will have a web interface that will show you what algorithms are supported, and you can upload the local file. You can select other files from URLs, it would take too much to go over all of this. You can explore it on your own. And for folks, I know Mia and Jasaraj in particular are interested in doing that with VCell, and we'll take this offline, but whoever is interested in running on their own HPC resources, any of these fully curated, the ones with 5 stars simulators, you can do that and script them to any extent that you want. Any shell script, you just change your models, edit your models, just make sure it's an omics file, a valid omics file, and you can run any of these simulators on any HPC cluster through any scripting. So that's all I wanted to show at this point.